All right, so when we prove this identity, which side do you think is the most difficult to maybe look at, or which one's the most complicated side here? The left. Okay, so just kind of keeping with notation, we would say like left-hand side is equal to 1 minus sine squared theta. Mouse died already. Hold on. We go 1 minus sine squared theta over 1 plus cotangent squared theta. Now, are there any substitutions there that you notice that we could maybe make pretty easily? Okay, 1 minus sine squared is cosine squared. Okay, and 1 plus cotangent is the same thing as what? Cosecant squared. Okay. Not the only way you can do this or have to do this, but why is that beneficial? Because we know that this can be rewritten as cosine squared over 1, then divided by, what's cosecant? 1 over sine. Okay. And now if I have a fraction divided by a fraction, you're going to take that one there and multiply by its reciprocal, right? Its reciprocal would be sine squared theta over 1. So is that going to give me cosine squared theta, sine squared theta, which that is your right-hand side. Okay. And when you guys have like things, obviously that is not identical right now to that because of the commutative property, right? If you want to add that additional step in, you can. When I read your word, I'm going to interpret that you understand the commutative property exists, and this is the same, but so you don't have to necessarily do it that way. Did anybody do it differently?
Yes.
Okay. How? Okay, so you took this over here. So this there you put 1 plus cosine squared over sine squared, right? Okay, then what'd you do?
Then I just took, I'm going to show you. Like this.
Okay, so this. Okay, so then. So you take the top, and let that be cosine squared.
Yes.
Get that one out of the way. So this one down here, then, did you try to follow it? So you're at this stage here.
Yes.
And then you went straight to that.
Yes.
Ow.
There's a step in between, but.
Yeah. Okay, all right.
Yes.
So you okay. So going through this, guys, and Vincent's right, but he has a step that he left out, did it in his head. But this becomes, if I'm going to add these together, don't I need a common denominator? Can I do that? Can I multiply the bottom by sine squared, the top by sine squared? So is that going to give me sine squared theta over sine squared theta plus now cosine squared theta over sine squared theta? Does that make sense? And if that's the same denominator, can't I just do this? Does that make sense, everybody? And now that would be cosine squared theta over, what's this numerator right here going to be? 1 divided by sine squared theta then, right? And if I multiply by that one's reciprocal, it's the same step as right here. It's going to provide me cosine squared theta, sine squared theta, which again is my right-hand side. Okay. I think those are probably maybe the most common approaches that we could use. You could probably do some other things that would probably be a little bit ugly, a little bit messier, but they will eventually get down to the same result. Okay, so that's 32. You guys want to do 34? All right. I do think these are benefit because when you see questions like this, and this is why in WebAssign I haven't assigned too many like this, if any, where they ask you to verify, because we have to look at your work to be able to do that, right? We have to analyze every step, and which I will do at some point. But there's no solid result out of these other than yes, they are true. All right, so again here, what's the more difficult part? Left-hand side. So I'm going to say the left-hand side is equal to, obviously, tangent squared x. 1 plus tangent squared x. Now, hopefully you start to realize that that is a nice thing. What does that thing equate to? Whenever you see a tangent, a secant, a cosecant, a cotangent paired with 1, whether it's plus or minus, you want to start thinking Pythagorean identities. Okay? Now, they won't always be 1, okay? But is that a Pythagorean identity? That's secant squared, isn't it? Okay? And the numerator is tangent squared. So at this stage, then, this is probably where it makes most sense to start changing things to sine and cosine. So the numerator is sine squared x over cosine squared x. And the denominator is 1 over cosine squared x, right? Can I multiply by that reciprocal? And what's going to happen with my cosine squares? Cancel, cancel. Gives me sine squared on top. Gives me 1 on the bottom. So that equates then to our right-hand side. Other things, you could do similar to what we did in the last one. And if we start with our left-hand side and we maybe right away go sine squared over cosine squared. Some people like to do this, just change everything. Everything into sine squared and cosine squared. So now this one here would be cosine squared x, cosine squared x, plus sine squared x over cosine squared x, right? But now, that denominator is just cosine squared x, common denominator. And now what does that numerator there become? 1. Okay. So all of this work that we just did right here in this step is that substitute. Actually, sorry, it's through 2 substitutions there. Does that kind of make sense? So we're bypassing our substitutions, which is fine, but if we bypass our substitutions, it makes more work for us, right? But ultimately, multiplying by the reciprocal, then we still get sine squared x, which is still our right-hand side. That hopefully maybe sheds light on or opens your eyes to the fact that if you forget an identity, which happens, it's I forget a lot of them, okay, or I mess them up, okay, which because there are so many, it makes sense that somebody's going to mess them up at some point, right? And so there's so many of them that are very similar that you might just mess up a plus sign or a minus sign somewhere. If you understand that you can always rely on or fall back on changing things to terms of sine and cosine, and then kind of using brute force algebra to find common denominators, to divide fractions by fractions, to FOIL, to factor, that kind of stuff, you should be able to still get down to the same results as if you were to use your substitutions. Is that okay? All right. Are there any others you guys want to talk about? Yeah, yeah. All right, before I guess we can we'll address tonight's homework, but let's, because I think probably some of them that we're going to want to use or talk about are the double, or sorry, not the half angles, which we kind of finished class with yesterday. Let's do a little bit more of a discussion of that, and then address some questions.